Let's look at electrolysis. Roll that graphic. Hi, I'm Paul. This is Science That Sticks, and in this session I'm going to talk and go through electrolysis. This is the idea that an electrical current can be used to break down a compound into its constituent elements. It's tricky for students, but it's actually pretty straightforward once you get the hang of it. So the first thing you need to know is exactly how do these ions form and how do we get them to conduct electricity? Well, first of all, formation of ions, go back to my video and watch ionic properties and forming ionic bonds. Let's assume that you know that. In order for ionic substances to conduct electricity, they need to be heated up to molten, in other words, they need to be heated to a liquid state, or they need to be dissolved in water. Now, in the lab, in schools, it's much cheaper, much easier and much safer to simply dissolve in water. Let's take, for example, sodium chloride, and we're going to say that we've dissolved it in water. So I'm going to express it as NaClAq. Let's say that we want to electrolyse sodium chloride. Well, I know, and you should know, that sodium chloride has positive sodium ions and negative chloride ions. When they are dissolved in water, they get separated from the giant ionic lattice. This means they're free to move, and because they are charged particles, they will conduct electricity. Easy enough. Now let's have a look at a typical diagram that you might see in a test, or maybe even on a board. So what we've got here is the cell. We've got two electrodes, and let's draw a beaker. Now this will have the sodium chloride dissolved within it. We also need to know what the positive and what the negative terminal is. It should be in chemistry exams already identified for you, but in case you're not sure, the big long one is plus, the little one is a negative. Dead easy. Now, whatever the charge is on the electrode, the opposite ion is going to be attracted to it. So this is positive. This positive electrode is called the anode. And the reason it's called the anode is because it attracts anions, negatively charged ions. So the chloride minus ions are going to be attracted here. This negative electrode is going to attract the cations. So it is called the cathode. Now, how do you remember this? Well, look at the little plus on the sodium. You could use it as a T. And when I teach this, I do use it as a T. So it becomes my cation, and it goes to the cathode. The two key points that you need to remember is cations are positive, they go to the negative terminal. If you can't remember cathode, just remember they go to the opposite terminal because it's oppositely charged. Chloride ions are negative. That means they are anions. Notice that I use a capital A and I really accentuate that negative. And the anions go to the anode, because it's oppositely charged. So what's going on at the cathode and the anode? Well, here the chlorides are losing electrons. So they form chlorine atoms and they lose an electron. Now, if you're a foundation tier student or combined foundation, you don't really need this very much. You just need to know that the gas that is produced here, in this case, would be chlorine gas. At this electrode, the sodium ions, the cations, these are going to be gaining an electron. And sodium is formed. But because sodium is more reactive than hydrogen, because this is dissolved in water, we end up making hydrogen at this one, this electrode, and chlorine at this electrode. And that's really all there is to know about it. So I think I've done a pretty good job. It's a good initial start. Remember those key points. Firstly, the ionic compounds can only conduct electricity when they are dissolved or molten, so heated up. The charges, the positive cations, will go to the cathode, which is negatively charged. The anions, which are negatively charged, will go to the anode, which is positively charged. Remember, opposites attract. That's it. As always, thanks for watching, thanks for taking part, thanks for watching, all that kind of jazz. And until next time, stay cool. Bye for now.